So just like with the law of sines, I'm never going to make you derive the law of cosines, just like I wouldn't make you derive the law of sines. But this is just where it comes from, and we have found that if we can, if you guys figure out where it comes from, you're better off figuring out when to use it. So I do expect you guys to write this down, but you would not have to do this on a test or quiz, okay? The law of sines can determine the measure of missing angles and sides of a triangle when the measures of two angles and a side. So if you have two angles and a side, whether the side is in between the two angles or not, you'd use law of sines. Or the measure of two sides and a non-included angle, like side-side angle or no. However, the law of sines cannot be used to determine the measure of a missing angle and side of a triangle when the measures of the two sides and included angle, side, or the measures of three sides, side, or no. Since the law of sines can only be used in certain situations, we need to develop another method to address the other possible cases. This new method is called the law of cosines. Okay, basically what that all means is we can't use the law of sines if we don't have an angle. So if we have three sides of a non-right triangle, we can't figure out what any of the angles are. So we have to use law of cosine. Okay? If we do not have, if we only have one angle and it's not across from the side that we have, we can't use law of sines. We have to use law of cosines. So this is the way to do that. If we could put our phones down and actually write this down, this would be good. Okay. To develop the law of cosines, begin with triangle ABC. From vertex C, an altitude K is drawn, separating side C into segments, C minus X and X. Why can they be represented this way? If this whole length is C, we just took X away from it. That's why. All right, the altitude separates ABC into two right triangles. So I'm going to just outline one of them in green, and I'm going to outline the other one in yellow to kind of clear up what we're talking about. Okay. We're going to use the Pythagorean theorem to write two equations, one related to K, B, and C minus X, and one related to K, X, and A. So if we're doing this first one first, we know that the right angles are here, correct? So I'm going C minus X squared plus K squared equals B, the hypotenuse, squared. Okay, and then I'm going to do the same thing for the yellow one. So what am I going to do for the yellow one? Anybody want to try? Yeah. What would I do for that yellow one? X squared equals A squared. Good. All right. Why do both equations contain K squared? Because they share a side, right? Because they both share a leg. Okay, now we're going to solve for K squared. So I'm going to take the easier one first. So I have X squared plus K squared equals A squared. I want K squared all by itself. What do I need to do? Minus the X squared, right? So I'm going to end up with K squared equals A squared minus X squared. For the other one, I've got C minus X squared plus K squared equals B squared. What am I going to do for that side? I'm going to subtract this whole thing, right? C minus X squared. So I get K squared equals B squared minus C minus X squared. Remember, I'm not going to ever make you do this on a test or quiz. So I know it is. But all I did was use Pythagorean theorem. We know how to do that. Then I solved for K squared. The thing that makes it this one weird is it has that C minus X squared all together, so it looks weirder. From this point, I'm going to make them both equal to each other. Do we agree both of them are equal to K squared? So I can set them equal to each other. So I've got B squared minus C minus X squared equals A squared minus X squared. Okay. Need you to make sure you got that so we can turn it over. Okay, turning it over. Okay, so I'm going to write from the other side. I have b squared minus c minus x squared equals a squared minus x squared. Okay, so notice that the equation in equation 3 involves an x. However, x is not a side of a, b, c. As a result, we will attempt to rewrite the equation in question 3 so that it does not include x. Begin by expanding c minus x squared. So this is like, you guys remember the box method? So it should be c and negative x and c and negative x, right? C times c is c squared, negative cx, and a negative times negative is positive x squared. So we are now going to get b squared minus c squared minus 2cx plus x squared equals a squared minus x squared. Yep. So it says 2cx. Oh, yeah, it's x squared right there. Okay. I know. I'm just going to tell you what I'm going to do next. I'm not going to actually do it yet. The next thing you would do, if you're ready, the next thing you would do is distribute that negative. Zach, you should be writing this down and not be on your phone.
30 plus.
So I'm going to have b squared minus c squared plus 2cx minus x squared equals a squared minus x squared. Okay, remember we're trying to get rid of the x squared first. Could I move one of the x squareds to the other side?
Yeah.
Okay, so I'm going to add x squared and x squared. What does that do?
2x.
Nope. A negative x squared plus an x squared is nothing. They cancel out. So I now have b squared minus c squared plus 2cx equals a squared. Now it's asking me to solve everything for b squared. So I'm going to subtract 2cx, and I'm going to get b squared minus c squared equals a squared minus 2cx. And now I'm going to add c squared to both sides. And I'm just going to change up the order a little bit. So I'm going to end up with b squared equals a squared plus c squared minus 2cx. Okay, we still have an x. All right. So the equation in question 5, should be in question 5, but we have it here. To eliminate the x from this equation, so you could do that, and then I'll catch you up when you come back. Okay. To eliminate the x from the equation, we will attempt to substitute the equivalent expression for x. Write an equation involving both cosine b and x. Okay, so we're going to go back over here. All right, we've got b right here. If we were going to do the cosine of b, it would equal what? What's the adjacent for b?
Okay.
Try again. The adjacent, and the hypotenuse is a. So we would have x over a. Okay, let's solve it for x. What would I do? You'd multiply both sides by a. So a cosine b equals x. So we're going to go back to the other side, and we're going to replace x with a cosine b. B squared equals a squared plus c squared minus 2ca cosine b. So the only thing I'm going to do with this is I like my stuff to be as close to alphabetical order as possible because it's easier to remember the equation. So I get b squared equals a squared plus c squared minus 2ac cosine b. Yep. Okay. There are 3 other equations which we are not going to find, but I'm just going to tell you what they are. We have a squared equals b squared plus c squared minus 2bc cosine a. And c squared equals a squared plus b squared minus 2ab cosine c.
How do you know when you use different?
So if you're looking for a, you'd use a squared. If you're looking for b, side b, you use b squared. If you're looking for side c, you use c squared.
What if the variables change? So it's like D, E, F.
You just choose one of them. You just make sure they're labeled. So if you're using D, E, F, that's the same as A, B, C, right? I mean, I would, like, that mixes me up. So I look at my triangle and I cross them off and I rewrite the letters.
Okay.
Okay. So I suggest it is harder to, I believe, use this way for angles. So you can manipulate this whole equation. So you can use a different equation for angles. So for example, if I wanted to find C, that turns out to be cosine -1 c squared minus a squared minus b squared all over -2ab. And I can show you how to do that, but I really would rather not waste our time right now because I would like to get working on this. But like, really what I did here was I subtracted a squared, b squared, then I divided by 2ab to have cosine c by itself, and then I took the inverse cosine. So we can do the same thing to find angle A and angle B. Cosine -1, it would be a squared minus b squared minus c squared all over -2bc. And this would be cosine -1 b squared minus c squared minus a squared all over -2ac.
That might be ABC.
Yep, -2bc, -2ac. And I'll put these on the board. Okay. Let's try one of these problems using this. Okay, I will put this on the board, I promise. All right, let's just do number 1. So I did not give you all 3 of each equation. I just gave you an example of them that we can use. So the first thing when doing the law of cosines is you're going to label the sides, just like we did with sines. We got b, we got little b, a, little a, c, little c. Then we figure out what we're trying to find. What does this say I'm trying to find here? A and b, so I'm trying to find little c. So guess which one you're going to use? Which equation? When it says we're trying to find side c, so we're going to use little c, so we use c squared equals a squared plus b squared minus 2ab cosine c. And that's right here at the top of your paper, that exact one. Now we're just going to fill everything in. We don't know what c squared is. We know a is 29 squared plus b is 13 squared minus 2 times 29 times 13 cosine 41, and I did that way too fast, right? Okay, so I did 29 squared plus 13 squared minus 2 times 29 times 13 cosine 41. This is really nice because it takes 2 steps once you get to this point.
Wait, why is there a
because this is side A. So there shouldn't be.
So just cosine one.
Yeah. So I'm going to put this in my calculator. I'm going to go 29 squared plus 13 squared minus 2 times 29 times 13, trig button, cosine 41. I hit enter. I get c squared equals 440.949. And then I take the square root of it and I'm finished. It says round to the nearest tenth. So I'm going to say 21. Yep, just square root it and you're finished. What's nice is once you figure out which one it is, plug it all in to your calculator, square root it, and you're finished. Okay, let's find, because to find the angle is even easier, so let's find one of the angles. Let's go down to number 7. Okay, I'm finding angle A, so guess which one you're going to use out of these 6? The A, okay. So I'm going to write that down first. I'm using A equals cosine -1 A squared minus B squared minus C squared all over -2 BC. And you want to make sure you put this in your calculator right or it'll mess it up. Gonna label, this is little a, this is little b, this is little c.
Why did you put a squared first when you said c squared?
It doesn't, because when you use angle A, you have to have A first. When you use angle C, you'd use C first. When you angle B, you'd B first. Okay? All right. So, my next step is to plug this in. A equals cosine -1, parentheses, that divide bar, 14 squared minus 9 squared minus 6 squared. And I'll say that again. Cosine -1, 14 squared minus 9 squared minus 6 squared. I don't know why it's so small. Okay. 14 squared minus 9 squared minus 6 squared all over -2 times 9 times 6. Okay. This is an important part to put this in your calculator correctly. Okay. So, hold on. It's just a plug and chug. Once you can figure out what things are, you're literally plugging them into equation and that's it. You know, like, so in that sense, it should be easy. Oh, man. Why? So, hold on, I want to make sure you guys are putting it in your calculator right, so I'll check your answer right this second. So here's my calculator. You hit trig button, inverse cosine. Then from here, everybody can get to inverse cosine by now, I'm hoping. From here, I hit control divide so it makes my fraction. Then I'm going to put 14 squared minus 9 squared minus 6 squared all over -2 times 9 times 6. I got 137.01. Yep. So it says round to the nearest degree, so we're at 137 degrees. On your phone. Yep, I will show you how to do it on your phone. It sucks on your phone, I'm going to be honest.
Oh my god. Wait.
So,
Wait.
I'm going to tell you this. There is Desmos on your computer, so if you have a computer at home, you could use Desmos, and that does make it easier. Okay, so you ready? Because this stinks on your phone. Okay. So, with your phone, I suggest you do this in 3 steps. Step 1, you can do the top. You can go 14 squared minus 9 squared minus 6 squared, and you get 79. And then you're going to do the bottom. So you're going to go negative 2 times 9 times 6. So you're going to go negative 2 times 9 times 6. That's step 2. You get negative 108. Then you're going to divide. You're going to go 79 divided by negative 108. Gives you this crazy answer. And then you hit second cosine negative 1, and you get the answer.
Okay.
It's not, like, if you have an Android, I believe it works better. It's easier. You just tried it, it doesn't? Okay. So, for the law of cosines, I just want to write down these steps real quick, and then I'll let you guys work. 1, label. 2, choose equation. 3, for sides, plug it all in. 4, for sides, square root. You're done. This is for sides. This is to find a side. If we're finding an angle with the law of cosines, we're going to 1, label. 2, choose equation. 3, plug in. Calculate. I mean, you're done. Like, it's only 3 steps. The only issue is if you're using your cell phone as your calculator, you just have to put it in slower. Each piece has to be put in. Okay? Questions? Okay, I'll leave this up on the board, but I am going to stop recording because we've taken so much time. All right.